Alright, today we're going to be talking about parallel and perpendicular lines, and specifically we're going to be working on how to find equations of parallel and perpendicular lines. But before we can do that, we have to know a little bit about them. So going in, parallel lines, as it says here, two or more lines that have the same slopes but pass through different y-intercepts. Now, what that means is you've got two lines on a graph on your chart, and they're going to stay the same distance apart on your chart, but they're going to pass through different spots on the y-axis. Remember that y-intercept is where they are on the y-axis there. So that's just a rough sketch of what they look like. And if you happen to notice, the symbol for parallel lines is just a rough set of parallel lines. They're always vertical, and it looks a little bit like an 11 if you're not paying attention, but it being in the context of parallel and perpendicular, know that two lines means parallel lines. What this looks like when you see an equation, if you had the equation y equals 3x plus 7, the slope on this is m, and in case you have forgotten, y equals mx plus b. If you have forgotten that, shame on you. Don't forget that. It's important. Where m, let's change colors on that. M is your slope, and b is your y-intercept. Again, y-intercept is just a fancy name for where it crosses the y-axis. So on this one, we need to pay attention to the slope. Notice that the definition says they have the same slope. Sorry, moving that around there. Parallel line says they have the same slope, and they have different y-intercepts. Now, if they have the same slope and the same y-intercept, they're the same line. So they can't be parallel to each other. They're just the same line. We're going to worry about that a little more later, but just something to know there. So if we're trying to find whether or not two lines are parallel or not, all we need to pay attention to is the slope. So if we've got this equation here, y equals 3x plus 7, and we have y equals 3x minus 9. If we look at the slopes on these, they're the same. Same slope means that they are parallel lines. All it would take for them to not be parallel anymore is for me to change either slope. It doesn't have to be both, but either of those slopes to be changed. So, for example, if I were to use these two equations, that looks almost like I've used the same two, but if you look closely, I've changed the slope on this second one. Remember, slope is the coefficient, or that number in front of x. So in the top equation, my slope is 3. The bottom equation, my slope is negative 3. These are not parallel. can't just look at the number. You have to pay attention whether or not those are exactly the same. So 3 and -3 are not the same number. That's an important distinction there. A lot of people will mess that up because they see the number, they see a 3 as all they pay attention to. Don't pay attention to one's positive and one's negative. And those are definitely not parallel. Perpendicular lines, two lines that intersect at a 90-degree angle. The slope of these lines are negative inverses of each other, and we're going to talk a little bit about what a negative inverse is. But again, if we're talking about on our graph, perpendicular lines are going to be two lines that cross. I'm going to show you the easiest version here, and then a little harder one, at 90-degree angles. Now, when they give you these, they're going to be giving you equations. They're not going to give you a picture, and it's not going to be nice and neat like this, and they're not going to have the little box in the corner. We're going to have to be paying attention to our slopes, because again, it tells us in our definition to look at the slope when determining if it's a parallel or a perpendicular line. So, also if you've got on a grid, I told you I was going to show you a little harder to tell, because they may have one more like that. It's a little harder to tell whether or not it's perpendicular or not. Now again, we're going to be looking at the slope of these lines, and before we can determine whether or not it is perpendicular, we need to know what negative inverse means. So I'm going to go over into a corner here, and I'm going to talk about negative inverse for a second. So I wrote these words apart from each other a little bit so we can talk about them separately, exactly what they mean, especially in context here. So the negative, if we take the negative of something, what we're doing is changing the sign. So an example, if I'm finding the negative of 5, it's going to be -5. So all they did was change the sign. So it went from +5 to -5. Also, I could go from, -17 to +17. The negative is just changing the sign, either from positive to negative or negative to positive. No trick there. The inverse is a little different. The inverse is something's reciprocal, and you've probably heard that word and have probably forgotten what it is. Back 100 years ago, when you talked about fractions on a regular basis, if you had the fraction 1/3, its reciprocal would be 3/1, which actually simplifies to 3, and we'll work on that a little more. If you had 5/4, its reciprocal would be 4/5. So this is literally, we're flipping it upside down. And that's one way to think of it, is flip upside down. Now, an example I'm going to give you is they'll want you to find the negative inverse of numbers. So again, let's do a couple quick examples of how we do that, putting those two things together. So both changing the sign and flipping it upside down. So let's see what that looks like. Alright, so I've moved us a little bit, and I've left these guys down here so that we can reference back to them. But if they want us to find the negative inverse of 7. Okay. First thing we're going to do is we're going to change the sign. So this goes from +7 to -7. That's the negative that's the negative part of the negative inverse. Now the inverse, we're going to flip it upside down. And this is the part that confuses people a little bit, because they're going, Mr. Mitchell, it's a 7. I can't flip it upside down. That looks like an L. You got to remember, whole numbers can be written as fractions if you write them over a 1. So if I make this, turn this into -7 over 1, I can now flip that upside down. So my inverse, again, remember we talked about the inverse just being flipping it upside down, would be -1 over 7. Now you don't necessarily have to write all those steps out, but I did it so that you can see where this came from. Negative inverse of 7 is -1/7. So again, thinking negative like opposite. So if it was +7, it's -7. If it's -5, becomes +5. You're going to change that sign, and you're going to flip it upside down. With fractions, it's real easy, because you just put the numerator, or that top number, on the bottom, and then the denominator, or that bottom number, on top. So you just swap the numbers. With a whole number, it's almost as easy. You just have to remember that whole number's over a 1. That's going to be important that you remember to do that step, because it'll come up again later. So if we do another one of those, I'm going to go over it, but I want you to pause the video just a second, and I want you to see if you can find the negative inverse at -5/7. Just give it a shot real quick. Pause it. I'm going to wait a second, and then I'm going to go over the answer. Alright, so I'm going to go straight to the answer, which is +7/5. And we get that by changing the sign. So it's negative here, becomes a positive. And the inverse means we flip it upside down, so we're going to swap those two numbers. So 7 goes on top, 5 goes on the bottom. That's the negative inverse. Okay. Now that we know that, we can look at actually identifying perpendicular lines. So we're going to look at y equals 3x plus 7, y equals negative 1/3 x plus 7. So all you're going to look for is that slope, just like we did before. Now, something that's interesting about perpendicular lines, you notice parallel lines had to have different y-intercepts. Perpendicular lines do not have to have different y-intercepts. They can be the same. They don't have to be. They can be different y-intercepts. Now, all we're doing is looking at our slope here, 3 and negative 1/3. So for it to be perpendicular, we have to look and see, are they negative inverses of each other? So we go from positive 3 to negative 1/3. There's a sign change there. We went from positive to negative, so there's half of it. Now we have to look and see if it's in the inverse, which is where we flipped it upside down. To do that, we're going to take 3, and remember, whole number goes over 1. And we're going to see the inverse would be flip that upside down, so 1/3. So we've changed the sign from positive to negative, and we have an inverse. So those are, in fact, perpendicular. That's how you identify perpendicular lines, is looking at those slopes and determining if they're negative inverses of each other. If they're not negative inverses, they're not perpendicular. An example of ones that are not perpendicular y equals 3x plus 7, y equals negative 3x minus 5. Remember, B here, our y-intercept, doesn't matter for perpendicular lines. Doesn't matter at all. All we're looking is that front number. You got 3x and negative 3x. So we have to look to see if they are negative inverses. So we go from positive 3 to negative 3. So there's the negative part of it. But I look at my inverse. If I look at my inverse, I go from 3. Remember, I would need to put that over a 1. To go to my inverse would be 1/3. But I don't have 1/3 on the bottom. So these are not perpendicular. Alright. We're going to start off by just identifying parallel and perpendicular lines, and we're going to identify what the slope should be for them to be parallel and perpendicular. So we're going to be creating which slope is appropriate, and then we're going to be working on identifying whether or not those slopes are parallel or perpendicular, or neither. That's an option, not being either one. And then we're going to finish up with actually creating some equations, and that one tends to be the harder part. That's why we're saving it for last. So if you don't have it out already, go ahead and take out worksheet 29. And they've got a chart set up here. They give you an equation. First thing they want you to do is to identify the slope. Then they want you to tell what the parallel slope would have to be, and then what the perpendicular slope would be. Again, we're not worried about equations, so on this, none of it nothing on this sheet. We're never going to pay attention to B. Okay, and we're just going to pay attention to M. So going through this, the first thing it wants us to do is to identify the slope. Remember, the slope is always in front of the X. So the slope is 1/2. Now, the parallel slope, if you remember, parallel lines have the same slope. So in this one, the slope is going to be 1/2. All the way down, these two columns should be exactly the same, because parallel lines have the same slope as the original line. So all the way down, these two columns should be exactly the same. For perpendicular slope, we need to do the negative inverse. So the first thing we're going to do is we're going to change the sign. And we're going back to the original slope. So it's a positive. So our perpendicular slope is going to be a negative. The inverse means we flip it upside down. So the 2 goes on top and the 1 goes on the bottom. And when we write that, we have 2 over 1. And we're actually going to simplify it just a little bit, because 2, and we always are if we can. So 2 over 1 simplifies, rather, negative 2 over 1 simplifies to negative 2. And that's your slope on there. I'm going to write both of those for right now so that you can see where this came from. We flip that upside down and change the sign. Next one, we're going to do the same thing. Again, looking at that slope right there in front of X. So we're going to start off, the slope is negative 3. And as I said a moment ago, parallel slope is exactly the same. So we're going to copy that over. Slope on our parallel line should be negative 3. Then we're going to look at our perpendicular slope. So negative inverse. First thing we need to do is change the sign. So it's already a negative. So my answer is going to be a positive. Then I need to take the inverse. So it's 3. But remember, 3 I can put over a 1 and make a fraction. And then I'm going to flip it upside down. So 1's going to go on top and 3's going to go on the bottom. So I'm going to have 1/3. So you notice I changed the sign. So from negative to positive. 3 is like 3 over 1. So the inverse of that is flipped upside down, becomes 1/3. 1/3 doesn't simplify any, so I leave it alone. I'm not going to go through all of these, but I'm going to go through some of the trickier ones. So if you will skip on down, I'm going to look at this one here. I'm sure you can see which one I'm talking about. We'll look at this one. The reason this one tends to be tricky is because people say, Mr. Mitchell, there's no slope here. There is a slope. Anytime we're looking for slope, we're looking for the number in front of X. And if there's not a number written, there's an invisible 1. Always. There's no exceptions to that rule. If there's not a number written, it's an invisible 1. So your slope on this one is 1. The parallel slope, remember I said these two are going to be the same because parallel lines have the same slope as the original. So it's also going to be 1. Now, we need the negative inverse. And remember I told you, anytime you got a whole number, if you put it over 1, is going to give you the fraction form of it. So the first thing we need to do, we need the negative of it. So it's a positive 1. That's going to make it a negative 1. So I put my negative down. And now I've got 1 over 1. So I'm going to swap that because I need the inverse. So I'm going to put the 1 on the bottom. and put the one on the top, and it happens to look very similar when I'm done. Excuse me. Now, remember, we always simplify if we can. So 1 over 1 happens to be 1. So my perpendicular slope when I'm finished is -1. And that tends to confuse people a little bit because you're going, Mr. Mitchell, all I did was change from positive to negative. But the inverse of 1 is still 1. It's one of those special cases. It's one of the very few special cases. So if you come across a slope of 1, know that the perpendicular slope, that inverse, is still going to be 1, but you're going to change the sign because you need the negative inverse. Okay, this one's pretty straightforward. I'm going to let you do it on your own, as are these two here. So I'm going to move just a little bit here and get to some of these trickier ones. I'm going to start off right here, 2y equals 4x. Now, if you will notice, there's a couple things different about this one. One, we don't have a b, but I told you on these, b doesn't matter, so I don't care at all about b. But if you'll notice, there's a number in front of y. We need this in slope-intercept form, y equals mx plus b, so we need y all by itself. To get y by itself, we got to get rid of that 2. So this is 2 times y. To get rid of it, we do the opposite. So instead of multiplying, we're going to divide by 2. If I do it to one side, I got to do it to the other. So my new equation, those 2's cancel out. I get y equals 4 divided by 2 is 2. My x doesn't change, so my new equation is y equals 2x. Now, I'll look at the m on my new equation. The m on this one is 2. That means my parallel slope is going to be 2. Now I've got to find my perpendicular slope. That's going to be my negative inverse. So first off, I'm going to change the sign. So I go from positive to negative. Any whole number I have, I'm going to put over a 1 to be able to do my inverse. So 1 goes on top, 2 goes on the bottom. So the inverse of 2 is 1/2. I check to see if it'll simplify, but 1/2 does not simplify, so the perpendicular slope is just -1/2. Anytime you see anything with y, or if you've got anything on the same side, you've got to solve and get y by itself. You did that a lot during 1a, getting y by itself, so I know you know how, but that tends to be something that people struggle with, so I'm still going to go through at least one more example here. I'm going to leave this one for you to try because, again, it's a lot like this one. You're just going to divide by the number in front of y first. You're going to get a fraction over here. Let your calculator help you. This next one down here, 4x minus 5y equals 20. I'm going to move just a little bit so that I have some room to work. You may want to use a separate sheet of paper or use the back of this sheet. But I'm going to go down here, 4x minus 5y equals 20. If you're just trying to write in that tiny little slot at the bottom, you're going to run out of room. So, like I said, you may want to try the back of this sheet. You may want a separate sheet of paper to do your work on. So, first thing I'm going to do is I'm going to move my x term to the other side, and I'm going to move the whole thing. Anytime I move an entire term, I'm going to add or subtract, depending on which one I need to do. So if I've got a positive number, I'm going to subtract to get rid of it. So I subtract 4x from both sides. Now notice I didn't line it up with that 20, and that tends to make it a little easier for people. That way they don't mistakenly try to subtract 4 from 20, because you can't do that. I have to keep x's with x's, numbers with numbers. So those cancel out. Now bring down everything that's left. Negative 5y equals, I'm just going to rewrite this so that my x's are in front. If you did 20 minus 4x isn't going to change anything. Just remember that that slope is always in front of the x value. So you really got to pay attention to that. And then I'm going to get rid of part of a term. Anytime you're going to split up a term, you're going to divide. So I'm going to divide that by negative 5. If I do it to one side, I got to do it to the whole other side. So what I get here, those cancel out. I get y equals negative divided by a negative is a positive. So positive 4/5 x plus 20 divided by negative 5. So give me negative 4. So now that's the equation I'm paying attention to. And again, all I need is m, that slope in front of x there, is what I'm going to be paying attention to. So if I go back up here, my slope is 4/5. That means my parallel slope, as it has been on all of my other examples, it's going to be exactly the same. So we got 4/5 again. My perpendicular slope is going to be the negative inverse. So I change the sign. So I go from a positive, over here is going to be a negative. Inverse, on this one I've already got a fraction, so I don't have to set it over 1. I'm just going to change top and bottom numbers. So 5 goes to the top, 4 goes to the bottom. And when I write that, I have 5/4. Always check and see if that simplifies. 5 divided by 4 doesn't simplify anymore. They don't share any common factors. So negative 5/4 is my perpendicular slope. So that next one, almost identical. I'm going to leave it so that you have the opportunity to solve it yourself. I do actually want you to try to solve it. This next one here, y equals 9. And this is where you're going to need to go back and remember something from 1A. And I'm sure your teacher probably showed you. It's possible you haven't seen it, but I think most of our 1A teachers used Hoy Vux, or Vux Hoy, depending on how they did that. And that's just a reminder of your special cases, your special lines, your horizontal and vertical lines. That the horizontal lines have 0 slope, and the equation is y equals a number. And that the vertical line has an undefined slope, and the equation is written as x equals a number. So if you look here, we've got a horizontal and vertical line, and we got to figure out which one's which. So y equals a number. That's going to be this one. We're going to use Hoy. That's a horizontal line. So what's our slope on a horizontal line? Well, our slope is 0. So we put 0 as our slope. And it's important to realize that that's where that comes from. You've got 0 slope here. Alright, it's because there's a horizontal line, y equals a number, brings that straight up here to 0. Remember, parallel is always going to have the same slope. So we're going to write a 0 in there as well. Negative inverse for perpendicular. So we start by writing something We got a whole number, we write it over 1, we flip that upside down, we get 1 over 0. Now, if you type that in your calculator, if you want to give it a try, what's going to happen is you're going to get an error message because you can't divide by 0. But if we'll think for just a minute, what's the opposite of a horizontal line? The opposite of a horizontal line, or at least the inverse of it's going to be a vertical line. So, what's the slope on a vertical line? And it's undefined. So I'm going to go from a 0 slope here to an undefined slope here. And there's no symbols or anything for undefined. And yes, I want you to write the whole word and don't be lazy. You people come up with horrible abbreviations for that word. So, this next one is x equals a number. And I'm going to go through this one, even though you could probably figure it out. If you have, go for it. If you haven't, pay attention. So we got x equals a number for our equation. So we're going to have a vertical line here, which means our slope is undefined. Okay, undefined slope goes up here, in that first box. Parallel slope. Remember we said those two columns are always the same. Always the same there, so we got undefined. And again, this means we have something over 0. We're going to try to flip that upside down, but we don't have to if we can think again. So here, we have a vertical line with an undefined slope. Before we said the inverse, or the opposite of a vertical line, is a horizontal line. So, our slope for our perpendicular line should be 0. And I generally get somebody here asking themselves, well, shouldn't it be negative 0? Well, negative of 0 is still 0 because you don't have a negative or positive 0. It's a no value, so positive and negative don't apply to it. But yes, for the negative inverse, you would change the sign. But 0 isn't positive or negative. It's neither, so don't have to worry about that. Alright, moving along to our next worksheet. I'm actually jumping ahead just a little bit. I'm going to come back to 30 and go straight to 31. Now, in case you didn't pick that up from what I was saying in the video, I want you to finish the ones I didn't do on 29 yourself. So you do need to still fill those in before you turn it in. Don't give me a sheet with those blank. This entire sheet is just to determine whether or not it's parallel, perpendicular, or neither. Neither is an option. To do that, we're going to be looking at the slopes they give us. They take it out of the equation, they get rid of it entirely. It doesn't matter, all you need is the slope for parallel and perpendicular. So, I'm going to move this sheet just a little bit so we can see more of it. I'm not going to do all of these, but I'm going to do a couple examples here. Show you what you're looking for. So you got to test each one. First off, this first one is 11. Then we have negative 11. So, first question to ask yourself for parallel is, are they the same? If they're not the same, it is not parallel. And here's what we're going to do. We're going to give ourselves multiple choice options here. Parallel, perpendicular, or neither. Okay? Remember, those are the symbols for parallel and perpendicular. N is going to be for neither. So, first off, are they exactly the same? The answer to that is no, because one's positive, one's negative. So, it is not parallel. Then we're going to ask ourselves, are they negative inverses of each other? So, first we check negative. So I go from a positive to a negative. Okay, that works, but then I need to do the inverse. So 11 would be 11 over 1, and the inverse would be 1 over 11. And if I look here, that is not negative 1 over 11. So it is not perpendicular. The only thing I have left is neither. Okay. So you're going to give yourself that option on each one. If you would like to write the symbol for parallel and perpendicular, you may. If you makes you feel better to write the words, you can. But if you'll write the symbol there for those multiple choice options there, give yourself a multiple choice option rather. Makes your life a little easier. So checking again. So are they exactly the same? 3/8, 8/3, they are not exactly the same. So it is not parallel. Then I'm looking for negative inverses. So this one's a positive, this one's a positive. It didn't change signs, so it can't be a negative. Even though it is an inverse, it has to be both. So it's not a negative. So that means it's not perpendicular. Again, we have a neither. Okay. So again, giving myself that multiple choice option there. So on this one, first thing I ask, are they exactly the same? 5, 5, yes they are. That means it is parallel. I'm going to write parallel for my answer. Again, if you want to write the word, if that makes you feel better, go for it. I'm fine with either. Okay? That's how you're checking each time. That's how you're checking each time. Looking for those things. I want you to finish that and turn that in. That shouldn't take you that long. We're going to move on to our next sheet here. Alright, notice I'm jumping over to page 32 here. This is the part I said we were saving to last. It tends to be a little trickier for people. So, here's what we're going to do. This one's wanting us to create an equation for a parallel or perpendicular line on these. And what they're going to do is they're going to give us an original equation. They're going to give us a point that we need to go through. So, we're going to need both of those for writing an equation. So this first one says write the equation of a line passing through the given point parallel highlight there, parallel to the given equation. Write your answer in slope-intercept form, which is y equals mx plus b. Now, if you were taught in 1a the equation y minus y1 equals m times x minus x1, you can use that equation here. You're going to plug in the m that you need. You're going to plug in the x value. You're going to plug in your y value. And you're going to solve for y. I'm going to show you a way that you may have been taught that I think is a lot easier when doing parallel and perpendicular lines. And what it is we're going to take the original equation, because that's the one we're trying to figure out something parallel to. We're going to take that original equation, and I'm going to zoom out a little bit here so that I've got some room to work. You're probably not going to be able to fit it all in that little box either. So again, a separate sheet of paper would be handy for you. Or you could use the back. Okay. Now, parallel lines have the same slope. So we're going to keep this m. It's going to stay exactly the same. If we're doing perpendicular, which we are going to do one or two down here, we're going to switch that and make it the negative inverse first. But since we're parallel, we're going to keep it the same, which makes our lives easier. What we're going to do is we're going to copy down our slope here, 2/3. We're going to replace the 1 because we don't want the same b. If we keep the same b, then we have the exact same line, and we don't want the exact same line. So what we're actually going to do is we're going to replace it with the letter b, and then we're going to substitute our x and y values. Give myself a little more room there for my y value. Now, they're nice enough to give us an x and y value. If they didn't, we couldn't do this. And what I'm going to do is I'm going to zoom in a little bit there, and hopefully I don't make anybody motion sick. And they give us an x value of 3 and a y value of 4. That's that point that we're passing through. So what we're going to do is we're going to plug those in for our x and y's. So again, zoom back where I was. And I'm going to plug in x equals 3 and y equals 4. And in case you're confused where that x and y came from, it's right here in that point that it gives us. So now what we're going to do is we're going to solve for b, which is right here. We're going to get that by itself. So 2/3 times 3. If you are bad at fractions, use your calculator. When you multiply that out, you get 2. So all I did was I multiplied 2/3 times 3 and got 2. Now I'm going to move that 2 to the other side. Anytime I move an entire term, we talked about this earlier, I add or subtract appropriately. So I got b equals 2. Now, this makes our life much easier, because if we're talking about y equals mx plus b, alright, when we're done, what we're going to replace is we're going to replace that m and that b. Those are going to get swapped out for our final equation. Now, we just found b. We already had m. That's from the original equation. So all we have to do now for that equation is plug those in. Y equals the m we found from the first equation, which is going to stay the same, it's 2/3, x plus the b we just found by plugging those x and y's in, 2. This is the answer. That's the parallel equation. So what we're going to do, we're going to zoom in. We're going to write that on that line. Y equals 2/3 x plus 2. And if you compare this equation with the original one, everything is the same except the b value. And that's something that's going to be true on all parallel lines. Everything's going to be the same except the b value. So you could actually take for your answer to begin with and copy down that first part of that equation on all of those, because they're all going to be the same. And what you're going to do is you're just going to plug in the x and y's and solve for b like we did on that first one. Alright? You might get a fraction for b. Okay, it's very possible. As a matter of fact, I'm pretty sure you do on here. I'm not going to swear to it at the moment because I don't have my key sitting in front of me. But it would be very possible for you to get b on as a fraction on some of your parallel lines, but even more possible on your perpendicular lines. So if you get a fraction, don't panic. That's possible. I'm going to let you practice on 2, 3, 4. You're welcome to go back and look how I did that again. If feel free to rewind or pause the video as necessary. But remember, I told you this part right here that I've underlined, it's going to be the same on all of those. So if you want to write those in, you've got half your answer already. Now that is not your final answer on these guys here, okay, on 2, 3, 4, but that is half the answer. If you'll plug those back in and find B, don't copy down the B here. Don't copy down 4 for number 2. That would be wrong. You've got to plug in those X and Y values first, like I did for number 1. If you want to pause those while that's fresh in your mind, and go ahead and work on 2, 3, and 4, I would recommend that. If you've been working while I've been talking, that's fine. But I'm going to switch now to go to perpendicular on the bottom. And for some of you, that's going to confuse you trying to shift gears. It's going to be almost the exact same process. But many of you, while you're thinking parallel, should stick with parallel. So if you want to pause that, come back to it when you've done 2 and 3 and 4, would probably be in your best interest. All right, last thing for today. Now we're talking about perpendicular lines. Again, that slope-intercept form, so y equals mx plus b. Now, unfortunately, on this one, we can't just copy things straight down because we have to change some stuff. Now, you should be able to still be able to get half your answer, and you'll see what I mean in just a minute, because we're still going to be using that slope and y and x, but we've got to change it because we're talking about perpendicular. And anytime we use the perpendicular slope, we're going to use the negative inverse. So I'm actually going to take a second and I'm going to change our slopes. So if you look on all those slopes, I'm going to do the first 2 for you, but I went ahead and underlined all of them. So negative inverse of 1/2. I'm going to start with 1/2. Negative inverse. So the first thing I'm going to do is I'm going to change the sign, which is negative, because I went from a positive 1/2 to a negative. Now I need to flip it upside down. So 2 goes on top, 1 goes on the bottom. And then simplify if possible. In this case, 2 over 1 actually simplifies to be 2. So negative 2 over 1 gives me negative 2. This is my new slope. It's going to be the slope of my new equation. So when I actually write it down here, it's going to be y equals 2x plus or minus something I actually have to solve to find. I can't just plug something in. But that's where that 2 came from. And I actually wrote a 2. I need to backtrack that, and I'm going to fix it. My apologies. And change that to a negative 2 like it should be. I'm sure some of you are sitting there screaming at it, Mr. Mitchell, you messed up. Good. It means you were paying attention. There. That's better. So that's where that negative 2 came from. Okay. Now, if you find that negative inverse for those others, you can get that much of your equation on all of those. Everybody should be able to make it that far, because I'm hoping I've done enough examples in negative inverse now that you could about do that in your sleep. So I really want you to at least have that much, but the next part you should be able to do as well. It's just like the last one, but I'm going to do that example again just in case you missed it. So I'm going to zoom over here to the side. So I've got plenty of room to work. I'm going to start by copying down my original equation. Let's go back to black here. Y equals 1/2 x plus 3. Now, I need to replace 2 things here. I need to replace my slope, and I need to replace b. Those are the things that get swapped out. Now, you remember on the other one, when we swapped out B. We didn't know what it was, so we put a B. And that's what we're going to do here. And this one, we need to swap out M as well. The last one we kept that and brought it straight down, but we can't do that on this one. Because we're doing perpendicular, we had to find that negative inverse, which we've already done. So what we're going to plug in here is -2. And then we're still going to substitute that x and y from the points it gave us right here. Again, x, y, give us an x value of 1 and a y value of 2. X value of 1, y value of 2. Don't get those mixed up. Okay? You don't write them in order there. You got to pay attention where the x is, where the y is. That's important. You will get the wrong answer if you don't do that. So now I multiply here. -2 times 1 gives me -2. I'm going to move that to the other side by adding or subtracting appropriately. In this case, adding. So I get B equals 4. Now you remember I said that's one of the things we have to replace. It's one of the things I have to replace there. So I've already replaced the 1/2 with a -2 over here. That's my negative inverse. Now I replace B with 4. So my new equation looks like y equals -2x plus 4. Yes, it's also possible to get a negative on some of these. So again, if you get a -b, that's perfectly fine. You don't on this one, but that's possible. So all we've got to do now, swing over here, write in our plus 4, and that's our final answer. It's the same kind of thing you did in Math 1 when they gave you 1A, when they gave you an equation through a point. The only difference is that they want something that's parallel or perpendicular to that line this time instead of just an equation through that line. So it's one more thing to know whether or not you keep the slope or whether you change it to the negative inverse. Now, 6, 7, and 8 are essentially the same thing. There are no tricks on there. When I get back, we will go through all of those. And like I said, you should be able to, on those, at least get that first half, because I think I've gone through the negative inverse enough times that you should at least be able to get the y equals and your slope. So we have y equals a number times x on all of these. I think you should be able to get those. If you finish that, you're done for the day. There's no additional homework or anything, and I will see you guys again soon.